Hello, in this video let's discuss fourth question of today's contest. You are given two integers num1 and num2 representing an inclusive range of num1 to num2. The waviness of a number is defined as the total count of its peaks and valleys. A digit is a peak if it is strictly greater than both of its immediate neighbors. A digit is a valley if it is strictly less than both of its immediate neighbors. The first and last digits are not peaks or valleys. Any number with fewer than 3 digits have waviness of 0. Return the total sum of waviness for all the numbers in the range num1 to num2. And the constraints are both are up to 110 per 15. For example, let's take 120 to 130. For 1 to 0, 2 is a peak number, so 120 there is only one, 121 there is only one. In 122 there is no peak because it should be strictly greater than both or it should be strictly less than both, but 122 is nothing, it is equal to 2, so 2 is equal to 2, so nothing. And finally 130, it is a peak. So finally only these three numbers have peaks or valleys and the sum is 3. So return 3. So firstly we can't do brute force. So we clearly understood that it belongs to DP because we have up to 15 digits, right? So we cannot blindly do the brute force. It will not pass the given constraints. So we want the answer from L to R. So L plus 1 to R. So what can you do? So what if we try to find a method that returns answer for 0 to R? So here in L to R it will be more difficult, right? So here we have to start from L. But what if we have some method which will give answer for 0 to R? For example, let's say we have the sum of waviness of all the numbers from 0 to R is X and 0 to L minus 1 is Y, and we want from L to R, so that is simply X minus Y, right? So 0 to R it is X, 0 to L minus 1 it is Y, so from L to R it is X minus Y, so that is what we want. So now we are able to reduce one thing, right? So 0 to R is easy to find than L to R, because 0 we can start from all zeros, but L is different, right? So now we got that if there is some function of X as answer from 0 to X, we can return function of R minus function of L minus 1. This is the first thing. And now let's start thinking about digits. So let's say our range is 120 to 145 and we are thinking to find answer from 0 to 145. Now let's assume the first digit is 1. So the first digit is 1 and then we are thinking about the next digits. So now we are at 1. So this should be less than or equal to 145 because we only want till less than or equal to X, less than or equal to R. So we are at 1. So what are the digits that we can keep here so that it will be less than or equal to 145? So we can keep 0, we can keep 1, 2, 3, 4. Can we keep 5? We cannot keep 5 because it is 145. So any number with prefix 15 is more than the number with 145. So this is what not we want. We want only less than or equal to 145. So we can use only from 0 to 5, 0 to 4. Okay, so we only want from 0 to 4. So now let's take this one. So if we take 0 here, then 1 0 dash, right? So 1 0 dash. What can this be? This can be from 0 to 9 because 1 0 prefix is already less than this number. So this number can be anything from 0 to 9. So 100 to 109, anything is fine. And now coming to 14 underscore. So now what? So can we keep 149? So can we keep 9 as last digit? No, because 14 is same as this. So we can keep only till 5 because we only want less than or equal to. So what will be the last digits now? It will be simply 0 to 5. So from this what we got? So we have to track something for every digit, right? Because we can have at most up to 16 digits. So when we are at single digit, we have to compute what all we exactly want. So some function of what is our answer. That is what we exactly want now. So now what the first thing we want? The first thing we want is we are at which digit, right? So obviously we have to know we are at which digit, whether we are at MSB or MSB minus 1. So this is 0 or 1 or 2 or n, which is the length of R. So we exactly want that so that we can do something when we reach finally as a base case. So we have to track this, else how can you find which number we are at? So that is the first thing. So we want the position which we are at. And now coming to next thing. So here what we exactly have seen. So we've seen that we want some boolean representing whether the prefix of R is same as the prefix for the given number or not. Why? Because let's say we want 145. So now we are at say second digit. So we can only, so here we have to know that we have to keep 0 to 4. So why not 9? Why not 9 is because the prefix till now is same as this prefix. So these both are exactly matched, these are tight. So if this is tight, then we can keep only from 0 to this number. We cannot keep 9, right? We can only keep from 0 to this. So we also want a boolean which indicates whether the prefix till now is same as the prefix in the given number, so that we can decide the number what we have to keep in the next digit. So if so, hope you got this. For example, let's say we have 1 4. For example, if we are at 1 3, then what can we keep here? We can keep 0 to 9, because the prefix itself here is less than 14, so we can keep any digit here. So 0 to 9. But what if we have 14 also, and also we have 14, and now we are thinking what to keep here? Then what? So we can keep only from 0 to this digit, because we are thinking about less than or equal to. So these both are we want right now. So this is tight. So position and tight are two values that we want. And now let's check what do we want further and what can we do. So now we are at 1 and we got up also based on tight. It is 9 if the prefix is less. If it is equal, it is still v of I. So now we got that we are keeping from 10 to 1 up. So this is what we have. And then so we fixed the 0. So we are looping from 0 to up. So we are at 0 to up, and for a digit we fixed that we are keeping 0. And after keeping 0, we have to think about rest of the suffix, right? So in a single loop, for this value this is fixed. So we have to think of the suffix. So what we can think? We have to think about the suffix, and also we have to think about this digit, whether it can contribute to any prefix, any peak or valley, because this is the place we have added. So in the next loop, what will come? In the next loop, 1 1 will come. So now we will think about this. It is prefix peak or valley and so on. So we energy it. We added this, so we have to check peak and valley because of this, and we have to think about suffix. So these two are the things when we are inside this loop. So now when we are at 0, so can we think of peak or valley for 0? No, right? Because the length must be at least 3. For peak or valley it is given that, but for 0 we only have 2. We don't have any before number, so we can't get any peak or valley here. So from this what we got, we also want to have a track of the active length so far. What is active length? The active length is simply the simply last 2 digits. So here when we are at 1 0, so when we are at 1 0 we have to get some boolean that we only have 2 digits so far, so we can't get whether it is peak or valley. But for example, if we are at 1004 and we are at this 4, and then we can have 3, right? Because there is active length of 3. This is active length of 3. So now we can think if this is 0 is a peak or valley. So we also have to add track active length also. So only then we can check whether the present digit will add to peak or valley. So this is what also we want. And then the next thing is, for example, let's say we are trying to find the answer for 145. So we are trying to find 145, and then coming to 0th digit we are at 0. So in the recursion we are going to next also we came to 0, and even the recursion we came to 0. So is this a valid number? So can peaks or valleys or anything can be detected in this? No, right? Because this is like a dummy value, because till now all the prefixes are 0, so it means the value is 0, so we cannot count this, right? So we also want to have a boolean whether to say that till the prefix till here is all zeros, or there is at least one non-zero. So that is what it matters, right? So if 0 0 0 0, this is one case, and any other than this, for example, let's say we have 1 0 0 or 1 1 0 or 0 9 0 or anything. So if you have at least one non-zero digit in the middle, it means that we started contributing the number, not simply adding zeros, right? So we also want this boolean, so that only then we can decide if this is actual number or not. Because 0 0 0 0 1, like for example 0 0 0, is this a valid number? No, because there is no non-zero number. So we also have to track this also, whether it really started or not. Is it a dummy number, or there is some actual real digit started? So that is what we also want to track. So can we have prefix zeros? Yes. So we have to track that also. So now we got many things, and also for example, let's say the active length is 3. So the active length is 3, and now we are checking if this number can contribute to peak or valley. So for finding it is a peak or valley, we have to know the before digit and before digit also, right? Only then we can think whether this is peak or valley, right? So we want the previous 2 digits also. Else how can we check if this is between these or more than this or more than this? We want these both digits also, right? So we have to track those also, because to decide peak or valley we want the numbers. Without numbers we can't compare, so we have to track this also. So what are the full things that we are going to store in the function? The first thing is position, because we have to know at which digit we are, and then we also want type, because only based on type we can get what is the next digit that we can fill, that is from 0 to 9 or 0 to up. And then coming to next, what is the next thing? We want whether all prefix till now is 0 or there is any non-zero, to know whether this is started or not, or this is dummy number. And then we also want active length also, because based on only active length we can find if we can check peak or valley. If active length is 1, then it means that the number is 2. Then what can we find? We can find nothing, because it must be at least 3 to find peak or valley. So active. And then we also want previous digit, and we also want previous digit. These are all the exact things that we want to get exact number given function of all this. So now let's check how to finally find the answer. We got what to track, but how to find the answer, that is the main thing, right? So now these are all the things we want. Position, type we already discussed. And then so now we have to find the new booleans for next set of digits, right? For example, let's say we are at 1 0, and now here we are checking 0 to 9. So for example, if we are checking 0 to 9, so for next rest of the suffix we want all the new booleans. We want whether this is still started or still tight, or what is the active length for this in this prefix. We also have to track all these for the next suffix also, right? So we have to update these values first. Let's check how to update this actually. So new tight. So how can you find new tight? So new tight is very simply, if it is tight till now, it means that if the prefix is same till now, and if the number we are placing is equal to v of I, it means that this is tight, right? So what is the condition for tight? So tight is simply these both prefixes are same, which is the tight which will come in the function, because this is the value, right? So what is function of position and tight? Function of position comma tight comma all. So these are all the values from here, but when we fix the values for here, then the new tight will be this tight. This is the tight, and this tight, and these both are equal. So for example, if this prefix is less than the initial prefix, then tight is 0, because already this is less, so we can place any number here. So the new tight will be 1 only if this tight is equal to 1, and then the current number we are keeping is the initial value which we have number in this digit. Only then this is new tight will be 1. So new tight we got, and new started also very simple. So if this started till now, it means it is started. So for example, if we have 1 here and we have bunch of zeros, and now we place it 3 here, it means that this is started, because we have 1 in the past. So this is started, and this is the new start. So if this is started, it already started. So new started is simply started or the present digit is non-zero, because if the old is started, now also is new started. So if old started, or if the old is not started, then the present should not be 0. So old started or the present number is not 0. This is the new started, right? So hope you got this. And then new active length. So new active length can also be found very simply. So now let's check how to actually find the answer now. So when can we find the answer? We can find only answer if we have new started, right? Because we already discussed. So if the number is dummy, if the number is all 0, then no need to find anything. We are still in construction, so no need to do anything. So we can actually find answer only if it is new started. So if it is newly started, only then, if else, only then we can try to find at least something. And now, so we initially went. So let's assume that new started is 1. It means that there is at least one non-zero digit. Let's assume 0 0 1 0 3. And now we went inside the loop. And now after going to inside loop, then what is the next thing we have to find? So the next thing is we have to track the before digit and before digit also, right? So we updated tight, we updated active length, we updated started, but we forgot about before and before. So we have to update that also. So how can you update? So how can you update is very simply, for example, so if the old is not started, let's say 0 0 0 0 0, and this is the position till now, and now function came call from here, this position. So now if we are keeping 1 here, so if we are keeping 1, what it means that the new started is 1, the old started is 0, but the new started is 1, right? So we came to the loop only if it is not, if it is started, if new started, it means that there is at least 1 non-zero. So if it is new started, it means that we came inside the loop, inside the if condition. Then what we are checking now, the main thing is we want the before digits, like we want before digit and before digit. So how can we check that? So if the old active is true, like if the old started is true, this is the one case, and old started is not true. So these two are things, right? If the old started is not true, if the old started is true, if the old started is true and old started is not true, so if this is not true, it means all the prefix till now is 0. So now the active length will become 1, right? Because we came into inside only if we are adding some non-zero digit here. So we are adding non-zero digit. What it means that active length is equal to 1, new active length is equal to 1, because if old started is 0, it means that all prefixes are 0. So if all are 0 and if we are keeping non-zero digit, then the active length will be 1, right? So we came inside this only if it is non-zero, it means that there is at least 1 non-zero. And if the old started is false, it means that all are zeros. So only 1 is the active length, which is the digit we added. So the new active length is 1, and what I would prefer digit, the before digit is 0, because all prefix is 0. So simply the before digit is 0, before digit is 0, and the new active length is equal to 1. So these are the updates that we require if the old start is false. And what if the old start is true? It means that it started somewhere else. Let's say we added 3 and started is not 0, started is true. Then what is the case? Then we can update the before digit, we can update before digit, and we can update current length also. So anyways, current length will be incremented by 1, because we added new digit, right? So plus 1, and then before digit is equal to before is equal to before digit, right? So before is equal to before, and this is equal to this. So simply when old started is true, it means that simply new active length will increase is equal to 1 plus old active. This is fine. And then before digit is equal to before digit. So we are shifting the digit, right? Let's say we have xy, and now we are adding this one. So originally this is the before digit for this, but this is before now. So simply before digit equal to before digit, and before digit equal to 1. And then now we have to check if we can find peak or valley. So when it is true only if the active length is at least 3. So if the new active length is 3, then find if the middle digit is less than both or more than both. If that is the true, then make s equal to 1. So if s equal to 1, it means that we are adding an answer. Whether it is peak or valley, we don't care, but s is equal to 1 means we got an answer. So now simply we can check because we have all three values. We have before and present value. So based on this, we can check if it is peak or valley. The middle digit is peak or valley, and then we can make s is equal to 1. And now find the answer for rest of the suffix. So we added this value and then find the answer for this, and then simply add the answer and then full answer. So this is what we have to do. So let's check dry run and let's check if we missed anything or everything is fine. So let's say we are at 1 to 3, and now the function call came for this one. So let's assume that we are keeping 0 here. So if we are keeping 0 here, we are checking this is peak or not, peak or valley or not, because when we add a number we have to check before number, right? So that next number will be existing, and before number will also be existing if there is no started, and so on. So when we are checking if 3 is peak or not, so let's say this is peak, right? So 3 is more than 0 and 2, so this is peak. So if this is peak, we are simply adding only ones here. So because we are making s equal to 1, so simply we are making s1. But what about this 3 in 1 2 3 0 0 1, 1 2 3 0 0 2, 1 2 3 0 0 4, and so on till 1 2 3 2 9 9. So we added s equal to 1, but in which we are adding, whether it is this or this or this or this, we are adding only for one. But what about all the rest of suffixes which will include this prefix, right? So here 1230 we added 1, but there can be many digits here. So for any digits here, we will get 3 as 1, like we'll get bonus answer as 1. So for any number which this 3 will existing, like 1230 as prefix is existing, we should add 1. But before we are not adding, we are adding only 1 to the answer. So how can we check that? So now what is the main thing we are forgetting? So we are adding 1. But what about this number? What about this? What about 1230003? What about this number? So we are adding 1, but we are forgetting the rest of the suffix. So how to modify this? How to change this? So we want to add the same peak for x numbers, where x is the number of possible numbers exist in suffix. So for example, let's say we have 1230, and now we added this here, and we are checking if this is peak or valley. So if we are checking this, for example, this is yes, so this is true. So 1 should be added how many times? 1 should be added in number of times where 1230 is prefix and the whole number is less than or equal to given number. In that many number of times we have to add 1. So, and is that simply 10 power digits left? For example, if I have 2 more digits, is simply answer 100? No, because that number should be less than or equal to given number. So we cannot guarantee that, right? So it is not simply 10 power something. We have to check more. So what is that? So now let's check the main condition for the code. So let's say we have the number is 2163, and now we are at 21 prefix, and now we got the recursion for this digit. So we added 0, we added 1, we added 2, we added 6, and so on. So now what is the number of numbers where this 1 will be added as a peak or value? So we are checking about this one. So we are checking how many ones, like how many numbers this 1 will be contributed as a prefix or as peak or value. That is the main thing for now. So if we clearly observe, for example, let's say we have 211. For example, this is the one we are thinking about, and let's say we got count one number of numbers with this prefix, and so this one should be added count one number of times when we are thinking about this. So for 211 prefix, we have to add 1 for count one number of times, and for 212. So for 212, let's assume that we got count 2 number of prefixes with 212. Let's assume only if this is peak. Like assume that 1 is peak or valley, right? So if this is peak or valley, then we are thinking to how many numbers we have to add this. So let's assume count 2. So this one will be added count 2 number of times also, right? And then we'll come to 216 also. So even come to 216, let's assume 1 is peak or valley, and then there are count 6 number of numbers with prefix as 216. So answer should be added count 6 number of times also. So indirectly what we are doing? So indirectly 1 is counted how many number of times? So indirectly this 1 should be added count 1 plus count 2 plus count 3 and so on till count 6 times, right? For example, 3 times here, 2 times here, 10 times here. So ultimately it is added 15 times. So this 1 should be counted 15. So from this what we got? So from this we got that till now we are only returning the answer. So till now what function of all returns? It returns only the number of answers in this function call. But we also have to get the other number. What is the number of numbers with this prefix? So that if we return this, then for every number we are adding, we can count this also, and then we can multiply yes by this number. So if this is a peak or valley, then we have to add for count 1 plus count 2 plus count 3 and so on, right? This is the contribution, net contribution. So now let's check more clearly. For example, let's say we have 21 dash. So now 211 and 212. Let's assume only these three we have. Let's assume that these three are the only things we have. And now what will function return? The function should return two values. The first thing is what is the answer for this subpart? What is the answer for 211 and so on? And this should return what is the answer for 212 and so on. this will return answer for 2 and 3 and so on. As we discussed, we don't like we want this, but we also want the number of numbers with this as prefix, and that should be less than or equal to number. So we also have to want other pair also. We have to return pair from the function where the first is the numbers with in that prefix, and then second thing we also want what are the number of numbers with this prefix and less than or equal to given number. So if we have these both, then what can we do? So if we return pair from the function, so let's say we are returning pair, and then this is the answer 1, and this is answer 2, and this is answer 3. And now let's say this is peak, so let's say this one is peak, let's assume. And if this is the peak, then what should be written from this function? This is the main thing, right? So we came here, we went through all recursion cases, but we have to return something to the parent. This is the one that we are concerned about. So what will return? So coming to count, it is very simple, right? So count is simply answer1 dot count plus answer2 dot count plus and so on, because the numbers ending with 2 1 dash is simply the numbers ending with 2 1 1 dash and 2 1 2 dash and so on, right? So the second parameter is straightforward. But what about first one? So what is the first one? The first one is the net answer, the net number of peaks and valleys in this prefix. So in all the numbers from 2 1 under 2 1 dash dash, it should represent the whole answer. And what is the answer? So we assume that 1 is peak, right? So 1 is peak, and it is contributing how many times? It is contributing this number of times. Answer count 1 plus count 2 plus count 3 and so on. Plus we got answer from these also, these 3 also, right? So what is the net answer? The net answer is simply if this value is a peak or valley, that boolean into the total number of count, because the answer for 2 1 dash is simply the sum for 2 1 1 dash 2 1 dash and so on, right? So it is simply boolean into this plus the answer from this, answer from this, answer from this and so on. So we are able to return the pair, right? We are able to return correct pair. So hope you got this. Take more examples, then you can clearly understand. Now let's check the code. So now return function of r minus function of l minus 1, and then convert to string, find the length, mem set both to -1, and then let's start the DP. So coming to DP, initially the position is 0, type is 1 because 0 0 prefix is matching, and now it is not started yet. The active length is 0, and the first digit is 10, and the second digit is also 10, which is simply like a base case. Dot first, because dot first is the answer. And now let's check that main DP. So if we reach at the end, then what? We reach at the last digit. So simply the answer is 0 and the count is 1, because that is also a number, right? For example, let's say 1 2 3 9, and now we came here. So if position equal to length, then simply return 0 comma 1. So simply return that. And now find if they are already memoized. So sum DP, count DP. So get these both values. If this is not -1, return the pair because this is already computed. And now make these both values 0 because we are finding the new values. And then find the up value. What is up? If the type is true, then only till v of I, else till 9. So this is up. And then loop through all the values from 0 to up, and then find the new type. What is new type? The new type will be 1 only if type till now is true and the present digit we are keeping is up. If these both are true, then new type is equal to true. And new start is simply if it is started till now, it is true, or if the present number is not 0, it is started. So these both we can find the answers. And now let's just initialize these 3. New active length is equal to old active length, new previous is previous, and new previous is previous. And now yes is equal to simply 0 or 1. If it is 0, it is not peak or valley. If it is 1, it is peak or valley. And now we can do only if it is new started. If the new started and if the old started is not true, then the new active length is 1, np1 is equal to d, because this is the value we are adding. So this is the previous value. And then if the starter is true, if the old starter is true, it means that we are simply adding the active length, and then we are simply moving the values. So let's say we are at xy dash. So y is the previous x is the previous number of y, but for this value this is previous, right? So simply shift the values to MSB. So new previous is equal to previous 1, and new previous 1 is equal to present digit. And then we can find peak or valley if the active length is more than or equal to 2. So like this simply new active length. So if the new active length is more than or equal to 3, it means that net active length. And now check if this is peak or valley. So if this is peak or if this is valley, then yes is equal to 1. And then after this, so find the next part for the answer. And now what is the answer? It is simply if this is peak or valley into next dot second. And what is next dot second? It is simply the sum of all. Like we are doing only for one digit, right? So we are doing only for one digit. So simply next dot second plus next dot first, which is the answer for that, and then new RC new count is equal to next dot second. So indirectly we are adding for every digit. So for example, we are at 1 to dash, we are adding for 1 to 0, 1 to 1, 1 to 3, and so on. And finally we are adding for 1 to. It is simply RS, RC. So hope you got this. If you have any doubts, comment below. See you in the next video.